Hi, so this session is on revision on linear graphs and equations, and we'll be going through some practice test questions. So with our first question, so part A is multiple choice, and the first question asks us the following points that are given. When joined on the Cartesian plane, what shape do they make? Now, just to recap, Cartesian plane simply means number plane, or what we can call a graph. So don't get confused by Cartesian plane. It's just the name of a mathematician. Now, to plot points, let's draw a graph. Well, here it is. And we know that when plotting points, x comes first and then y, just like our alphabet, x, y, z. And all we're going to do is, first of all, make sure you label your axes, the y-axis and the x-axis. And so first one, x is 1, there it is, and y is 2. So the point will be, I'll just change my color, just there. Next point that's given to us is when x is 1 and y is negative 1. So x is positive 1, y is negative 1. Down there, we plot that point. Next, we've got x is minus 2, y is minus 1. So go to the x-axis, x is minus 2, there it is. Y is minus 1, let's go down to minus 1. And there we go. And our final point, x is minus 2, y is positive 2. So go to the x-axis again, x is minus 2, up to positive 2 on the y-axis. And if we join these points up, we can see we get a, what shape is that? I think we can see it's a square. And that's it. And so for the multiple choice question, we just circle B. Now question 2, let's see what it says. Which of the following points does not lie on the line? And we've got a linear equation here. So there's a straight line in equation form, and we have to figure out, well, which one of these points doesn't lie on this line or doesn't belong to this equation. And to do that, we can simply use substitution. Just like using substitution when we had a table of values, let's do the same thing. Now, just quickly, if you wanted to, you could actually draw this straight line and then kind of see which one of these points doesn't lie on that line or isn't a part of that line. That may take you a bit longer. So what you could do, the method I'm showing you is we're using substitution. So if we write our equation here, y equals minus x plus 3, what you have to do is, let's pick the first point. X is negative 4 and y is 7. So instead of drawing the graph, we can actually do this. If x is negative 4 and y is 7, if I substitute when x is negative 4 into this equation, I should get y to equal 7. If I don't, this point doesn't belong to this straight line, or it doesn't belong to this equation. So when x is equal to negative 4, let's sub it into the equation. Y equals minus, now we know there's really a minus 1 there, or we can just put it in brackets, it's your choice. So in the brackets, x is now minus 4 plus 3. Now, two negatives sitting together make a positive, or minus 1 times minus 4 is a positive 4. And 4 plus 3 is 7. And we got our 7. So this point belongs to this line here. So A isn't an option. Let's see what other points we have. Okay, we've got B is when x is 2 and y is 1. Now you can do this mentally. You don't have to show working out because it is a multiple choice question. If you can't do it mentally, then just use working out. Let's do another example with working out. So our next point, we have when x is 2 and y is 1. So when x is 2, if I put it into the equation, I should get y is equal to 1. If I don't, then this point does not belong to this equation. So we've got minus, and x is now positive 2 plus 3. We know minus 1 times 2 is just negative 2. And negative 2 plus 3 is positive 1. And so this point also belongs to this equation, or to this straight line, because when x is 2, y is 1, and that's correct. Now let's try the next one. Let's try and do this one mentally. When x is 0, what is y? Well, when we know when x is 0 and we get a y value, that is our y-intercept. And do we have positive 3 as our y-intercept? Yes, we can see that the y-intercept is 3. So this is also part of the straight line. So when x is 0, y is positive 3. Now let's go to D. When x is 1, y is negative 2. Let's just do this one. with working out again. So there's this point. Let's do our check. When x equals 1, so if x equals 1, we should get y to equal negative 2. If we don't, then it's not part of this equation or this straight line. So when x is 1, let's sub it in. Y equals minus positive 1, or minus 1 times 1 plus 3. That leaves us with negative 1 plus 3, and minus 1 plus 3 is positive 2. Now, what do you notice? We got a positive 2, not a negative 2. So this point here, it does not belong to this equation or to this straight line. So when we draw a straight line, if we drew the straight line, we can see it's a negative gradient, so it's going down the hill. This point will not be a part of that line. It might be sitting out here. Every other point must belong to the straight line, or it does because we did our tests. So they all belong to the straight line, whereas this point here will be out there. So the answer for this one is D. D, this point here does not belong to this equation here. So our next question. The gradient of the following line is, and we've got some options here. So we know gradient means how steep a line is. And we've gone through the different types of gradients. There are 4 different types of gradients, and they are all here. We can have a 0 gradient, a positive gradient, an undefined gradient, or when we enter it on our calculator, we get an error, and also a negative gradient. Now look at this line here, that blue line there. It's horizontal, and we know whenever we have a horizontal line, the gradient is 0. So the answer for this one will be A, but let's just quickly go through the different types of gradients we have, just for some revision. So we have 4 graphs because there are 4 different types of gradients. The first one we looked at in the beginning of the unit was we can go up the hill, so that's a positive gradient. I'll just put positive like that. Opposite of positive is to go down the hill, so that was a negative gradient. So negative, or the negative symbol. The other option is we can just walk along the ground and not go up or down. So if we're not gaining height or losing height, we say this is a 0 gradient. And then the other option is the vertical line. And we know this one doesn't make sense because we can't go both up and down at the same time. And so this is undefined, or an error on your calculator. Okay, they're the 4 different types of gradients we can have. And with the 0 and undefined, just to recap on how to write these equations, just say this line was passing through the y-axis at positive 2, and over here this line is passing through the x-axis at negative 3. Now you can see that y can only be 2. So for these equations, for 0 and undefined equations, you either have y equals a number, and for this one you will have x can only equal a number. So these equations are special, they're a bit different. The positive and negative gradient, we have y equals mx plus c. Okay, we find m, we find c, and there's always going to be a y and an x for a positive gradient or a negative gradient, or you could say for diagonal lines. Whereas these ones, you can only have y equals something or x equals something. So for the 0 gradient, we can see the line cuts through the y-axis. At which number? At 2. So y can only be 2. X can be anything else. For example, at this point here, x could be, just say, if x was a positive 3 and y is 2. So x can be anything. It hits the line anywhere. But y can only be 2. Every point is when y is 2. And we know a line is made up of millions and trillions of points. Now, for the undefined, we can see that x, in this case now, this vertical line, it cuts through the x-axis. Y can be anything. For example, here, y can be, just say, positive 5, but x can only be negative 3. So every point on this line, x can only be negative 3. So the equation for this one, x will equal negative 3. So just remember, when you have a vertical line or a horizontal line, their equations look different to the form of y equals mx plus c, because you only see a y or you only see an x, depending on which line it is. Okay, for our next question, it asks us the gradient of the following line is. Now we know when we're given a straight line on a graph, we can find the equation of this. To find the equation, we first have to figure out what is the gradient. And we know how to do this. To find the gradient when given a line on a graph, you pick any 2 points, you calculate the rise and run, and you're done. But of course, the first step is, are we going up the hill or down the hill? So we can see this gradient is negative. So then negative gradient is going down a hill, so it's negative. That's our first step. And now you pick any 2 clear points. So there's a point given to us here that's quite clear. And I can see the line cuts through this axis here through the origin, and that's quite clear. So let's pick the rise and run between these 2 points. So we rise up, 1, 2. So our rise is 2 over, and we go across 1, so 2 over 1. And negative, so it's going to be negative 2 divided by 1 is just 2. And there's our gradient, okay? And also, just remember, if you wanted to go down from this point, 2 and across 1, you could have done that as well. Remember, we have taken care of our negative. So forget about any negatives and positives. Don't think, oh, it's negative 2 here, so we go negative 2 and negative 1. We know once we've taken care of our negative or positive gradient, we just go up 2 and across 1 units from one point to the other. So let's see if that's an answer. So it looks like it's E. The gradient is negative 2. Now our next question asks us to find the gradient, but this time we're given 2 points. Now there is, those of you who have been doing the challenge work, there is a formula you can use to find the gradient when given 2 points. And you learn that in year 9 and year 10. But another way of doing it, and I think this might be an easy way, is to use a table of values. Put these points in a table of values. So here are our 2 points, and now I'm going to get a table of values ready. I've only got 2 points, so it doesn't have to be too big. So X comes first and then Y. Okay, and now we know when given points, we have X first and then Y. X first and then Y. So the first value we have, X is 0 for this one. And what's X here? X is 2. And the first value in this one, we have Y is 1 and Y is 7 over here. Okay, and now we have to just use our skill in finding the gradient when given a table of values. And that is to find the patterns in Y and in X. So to go from 1 to 7, do we plus 10, minus 2? Well, we know 1 plus 6 gives us 7. So the pattern is plus 6. And to go from 0 to 2, well, we have to plus 2. And that's our gradient. That's our rise. It's a positive 6, and that is our run. So M will equal 6 over 2, and 6 divided by 2 is just a positive 3. So the answer for 5, it would be D. Gradient is positive 3. Now question 6 asks us the y-intercept of a line is 5 and the gradient is negative 4. The rule also means equation. So the equation for a line is, this one's pretty easy because we know that the equation of a straight line can always be written in the form of y equals mx plus c. And we know sometimes an x may not be there or a y may not be there, but it's still similar. So m, we know, is the gradient, c is the, so gradient, and c is the y-intercept. And they've actually told us that the y-intercept is 5 and the gradient is negative 4. So all you're going to do is put it into the equation. So y equals m is negative 4, x, and c is positive 5, plus 5. And there's the equation of a straight line with the given information. So let's see which one that is. Negative 4 plus 5, there it is. So it will be 6D. That was quite easy. Our next question says a rule or an equation gives the following table of values. So they've given us a table of values, and then they ask the y-intercept for the graph for this rule or this equation would be what? Now this one's quite easy because we know the y-intercept if you remember, the y-intercept is when x equals 0. So go to the x values. So here's x. We've got -3, -2, -1. And what do you notice? 0. So when x is 0, what is y? Y is 4. So this here is the y-intercept. When x is 0, y is 4. So the y-intercept would be e. And that's it. They haven't asked us to find the gradient. We know we can do that by finding the pattern. But that's it. Question 8 asks us the x-intercept of the line, and here's an equation. There it is what? So we know now the x-intercept, to find the x-intercept, it's when y is 0. So let's just do some working out. So here's our equation, and we know to find the x-intercept, it's when y is 0. So we make y equals 0 in the equation. So 0 equals, and we've got 3x minus 6. And all we have to do now is solve this. It's a basic equation to solve, and it's really easy. If you don't like x on this side, rewrite it. 3x minus 6 equals 0. And let's just solve for x. So we go, it's opposite of minus 6, we plus 6 and plus 6 here. So we have 3x equals 6. And our final step is to divide by 3. Divide by 3, and 6 divided by 3 is 2. And that's it. So the x-intercept, so when x is 2, our point is this, y is 0. Always write the point, and that's a point we can plot on a graph. So which option was that? Let's have a look. Positive 2, there it is, it's C. Now question 9 asks us the equation for a horizontal line passing through the point, and they've given us a point, is what? Now this one you have to really think about what is given to you. Otherwise, you won't be able to work it out. A key word here is horizontal. And we know when we have a horizontal line, the gradient is 0. So let's just draw a quick example of that. So whenever you are given information like that, always visualize what you have by drawing it. So an equation for a horizontal line, so a horizontal line is horizontal. And I know that in this case, y can only equal something. Okay, so y can only be something with horizontal lines. That will be what the equation will look like. And now it tells us it passes through which point? It passes through this. So there's the point given to us. Let's write it here. So the point is when x is -3, and what is y? Y is positive 7. So that means the line is passing through this point when y is 7. Remember, with horizontal lines, x can be anything. For example, if x was here and -3, I go up, y is going to be positive 7. If I go on this side, x is positive 3, what's y going to be? Remember, y can only be 7. So the equation for this line, because it's horizontal, y can only be 7. And that's the equation for this straight line. And so the answer would be B. Now, the next question, question 10, asks us which of the following is the graph for this rule? And if you notice, this equation here is not a linear equation. We know a linear equation, you have to be able to identify a linear equation. So a linear equation, if we have this, for example, y equals 2x plus 1, the powers of y and x are an invisible positive 1. If that's the case, then it will always give us a straight line. Okay, and we know there are 4 different types of gradients or different lines: up the hill, down the hill, horizontal or vertical. So a linear equation will give us one of these lines. As soon as the powers change for y or x, it is no longer a straight line. For example, if I have this, y equals x to the power of -1 plus 1, because it's a -1, it will no longer be a straight line. The graph will be something else. Same with this one, y equals x squared. Because the power is a squared, it will give us a different type of graph, not a straight line. Now, we can actually draw these different types of equations using a table of values. A table of values works for any graph. You can use this to draw any equation. Okay, so a table of values looks like this. So we put in some x values, find the y values, plot the points, and we can see what type of graph it is. Do that for this question. So I've got this equation here, y equals x to the power of 3, and let's set up a table of values for this. So here's a table of values, and we know when constructing a table of values, we put 0 somewhere. So we're including pretty much the whole graph, both sides, and we've got some negative values and positive values. And please make sure you go in a pattern. Now, because this isn't a straight line, we may not see a pattern straight away, and because it's not a straight line, the pattern won't be consistent. It may change. So to do this, we do it the exact same way as we did for a straight line or a linear equation, and that is, first point is when x is equal to -2, put it in the equation and see what we get. Now you must remember, you must substitute with brackets. So put the -2 in brackets instead of x here, and what's out there? We've got a 3. So this is saying -2 times -2 times -2. If you put this in your calculator and don't put brackets, so if you put this in your calculator, it'll give you a negative answer. And 2 to the power of 3 we know is 8. If you put that without brackets, the calculator will give you -8, and that is incorrect. Because there are brackets, put the brackets in the calculator, and then it will give you a +8. Because this here is saying -2 times -2 times -2. Oh, sorry. Sorry, I just realized I made a mistake. If we had a power 2, I'm just going to quickly show you something, just so it makes sense. If that was a power 2, we would have -2 times -2 to give us a +4, okay? And if this was a 2 here, so -2 squared, the calculator would give you a -4. Now, because we have a power 3, both answers will be negative, because it's an odd amount of negatives. So for this one, it's also a -8, because -2 times -2 is +4, and then +4 times -2 is -8. So when the powers are odd, the brackets don't actually matter really, because it'll always be a negative answer. But get into the habit of putting in brackets. So the y value for here is -8. So now when x is -1, we'll do it up here. So when x is -1, we have y equals -1 to the power of 3. And that will just give us -1. And when x is 0, we just have 0. When x is +1, we will have a +1. And when x is +2, we would have 2 to the power of 3. So we have it like this. Squeeze it in here. 2 to the power of 3 is just +8. Okay, so you notice how we've got -8, -1, 0, and then back to a +1 and a +8. So you can see how the pattern is changing, and it's not a straight line. Now all we have to do is quickly draw these points on a graph. So you can just draw a quick graph, and I've just got one here. So now let's plot these points and see what shape we get. So x is -1, y is -8. So we'll just imagine it's down here, so 7 and 8. So -8's here. So there's 1 point. Next one, x is -2 and y is -1. There's another point here. And just hold on 1 second, because the table of values is wrong. I put in the wrong values. Let me just fix it. Sorry about that. All right, so we got -1 and -2. And so we got -8 here and then -1. So you had the correct table of values. I just realized I made a mistake. So let's just start again. All right, so x is -2, that's better, and y is -8, so they'll be down here again. X is -1 and y is -1, so just here. X is 0, y is 0, that's the origin. And x is 1, y is 1. And x is 2 and y is 8, so it'll be all the way up here. And now if I join these points up like this, don't join them with a straight line, includes a bit of curves. Oops, sorry, a bit inaccurate. But what shape does that look like? If we compare that to one of these graphs, we can see it's this one here. Okay, so if you have a question like this, just get a table of values ready and put in some points for x, and you should be able to figure out which graph it is.